Hey students, I hope you're all doing well, no one's been sick, that your family hasn't been too heavily impacted by the coronavirus issue going on. Just as an update, we really don't know how long we're going to be shut down as a result of this. It's the plan of the district to try and come back on April 13th, which would be when we'd be coming back from spring break anyway. But the longer that people aren't taking social distancing seriously and the more that it spreads, the longer that this shutdown will potentially take. So we really are just kind of closed indefinitely at the moment. So for that reason, we wanted to make sure to roll out some distance learning, some online learning opportunities for you guys to basically remain engaged with your schoolwork while we're shut down, and it will give you an opportunity to basically raise your grades. How much, we don't know, but it's not going to hurt you if you're not participating, but it's definitely really valuable for you to be keeping your minds sharp. Especially if we end up coming back, because we're going to have to do finals anyway. But the big thing about this opportunity is that you are not going to be learning anything that's brand new. It's not really fair to you or to anybody who doesn't have a computer or Wi-Fi or anything like that to try and teach everybody something new, because then we're at like different levels and it's just not really right. So instead we're going to be kind of reteaching some of the concepts that we've learned throughout the year, or even in previous years, since we are 1B class and 1C class rather than a 1A class. So this could be some stuff even from 1A that we needed to use for this semester. So with that being said, why don't we go ahead and get into our first lesson today? So what I really wanted to do was continue to build on skills to keep the momentum going strong from what we were doing in our last few classes. I know that we were starting to do pretty well with graphing inequalities. I know there were a handful of us that were still kind of struggling a little bit with solving inequalities as well, but my goal is for us to put in some plans to basically be able to go back over graphing through slope-intercept form, y equals mx plus b, as well as solving regular equations and systems of equations before getting back into the inequalities, things that we were already going over and learning that we already got quizzed on. So first of all, I just want to go ahead and do slope-intercept graphing with you guys again. So just if we recall, slope-intercept would be y equals mx plus b. Now, when we look at this, the y equals mx plus b, what we see here is this is your y intercept and m over there is your slope. And the reason we call this slope-intercept is because those are the really big two key components, the key parts here, that are going to help you be able to solve and graph these types of equations. So basically, if we don't remember what these things mean, I'll go ahead and type it right here for you. So with this here, y-intercept is where the graph crosses or hits the y-axis line. And the slope is basically where you're talking about how much the line changes in direction as it goes on. And what we mean by that is rise, which is up or down, over run, which is always going to go right. So it's how much you're going to change your direction going up or down versus how much right. Now, when we're talking about using this stuff, we're not going to talk about like finding the slope today. I think we've kind of covered that before. We'll go back over it when we're talking about solving the equations. For now, I just want to focus today on graphing using the information you get in these types of equations. So if we know that y-intercept is where the graph crosses or hits the y-axis line, and the slope is how much it's going to change direction going up or down, depending on if it's positive or negative, over how far it goes right as it goes further on with the line, we can then just use these two pieces of information, as we see my new cat there running in the background, very excited about being outside. We can use those two pieces of information to just basically graph what we need to graph. So I'm going to go ahead and scroll this down just a little bit there. Now this is going to be kind of weird because I don't exactly have like a line feature on this internet whiteboard here, but bear with me. Oh, it was pretty straight up till there. That's good enough. Cool. Now let's say that we get an equation. And our equation here, I'm going to go ahead and write it in blue. Y equals 2x plus 1. Let's just give a nice basic equation. Now what I'm going to do is go ahead and change the colors for you here so you know which one is slope and which one's y-intercept. Now before I do that, I want you all to have an opportunity to think through it really quick, maybe even pause the video real fast. Tell yourself which one is slope, which one is intercept. If you're not really at that stage yet, that's totally fine. We're about to go over it. So I'm going to give you like a 3-second, just pause your video. And here we go. Okay, cool. So we're ready to go here with the slope and the intercept. So I'm going to erase both of these guys, and I'm going to put them in their correct colors. If you guessed that slope was 2 and y-intercept was 1, you'd be correct. Now, what does that exactly mean? Well, let's say that I go ahead and put some lines on here. That's good enough. All right, cool. That's enough lines for now. So let's say that I have my graph right there, right? The first thing that you want to do, I'm going to be able to get a screenshot of this on the whiteboard, is plot y intercept. So if I'm going to plot my y-intercept, my number is 1, right? Positive 1 would go up. Keep in mind, when you got x and y is up or down, x is left or right. So that's the first part. The second part I want to do is apply slope. Now when I say apply slope, that might be kind of vague for some of you guys. That's just the terminology we would usually use. Let me show you how that would work. So keep in mind it's going to go up or down. That would be plus or minus, so it depends on if it's a positive or negative number. Then right. Now what I see here is a whole number. This is not a fraction. What happens when you see those is that you're going to take the number that you see and go up or down that amount first. And if it's that whole number, not a fraction, you're going to always go right 1. Okay? So I'm going right here. I go up 1, 2, that's my number, and then I go right 1. 1 is our default. And I go ahead and plot that. Now all I've got left to do is connect line. So I take my 2 dots, and this isn't going to be the straightest line ever. Whoa! It went away. Why it went away, I don't know. Let's just go ahead and put that back here just for your visual. There we go. And it was connect line. Cool. I'm going to make this just a little neater for you. So we're going to be able to share this screenshot. There we go. Connect line. Cool. So in 3 steps, you basically get to see how you would use slope-intercept form to be able to make a graph. So just as a review of what we did here before we do another example, and before I'll cut you loose to do your own work on this part of it, we have equation here. 1, plot the intercept, which is this last number. Now, if this was a minus, I would go down. If it's positive, I go up. Plus 1. 2, apply slope. You go up or down the top number, or the whole number. In this case, it's a whole number. 2. And then right. Up 2, right 1. And then I just connect my lines. So that is how you go ahead and use slope-intercept form to graph in 3 steps. Let's do another example before I let you guys basically get your assignment here. So, I'm going to go ahead and erase this right here. I'm going to leave the steps up there. What I'm going to do is give the equation, and I'm going to have you guys practice. Okay. I'm going to show you how to do another one with a couple of different pieces to it, basically. So I'm going to start with my y equals, and what I'm going to do is we use red slope, so I'm going to go negative, I'm going to go 2 over 3, we'll go back to blue, x, we're going to go with green minus 2. Let's do that. Now, what we notice this time is our y-intercept, the green guy. Whoa, it's reverting. Why is it reverting? That was interesting. Never used this feature before, so sometimes it is going to be a little weird. Okay, negative 2/3 x minus 2. So we see our y-intercept there is at negative 2. That's our green, right? So what we have here is we go down to negative 2, and I plot it. Then we've got negative 2/3 as the slope. Now this time it's a fraction, right? So what we see is we got the sign minus, and then we see the 2, the top number. Now that means you're going to go down 2, down 2. And we always go right, the bottom number, 3. Right there. And then we have connect our lines. And there's our graph. So, all in all, that would be how you would do that. Wow, okay. This thing really doesn't want my stuff to stay. Probably because it's not a private whiteboard. But yes, that would be exactly how we would do that right here. So, basically, what I'm going to do now is take a screenshot of this guy for you guys, and I'm going to go ahead and in a separate video here that I'm going to upload, or a separate part to the video, I'm going to go ahead and just put on the screen for you some equations that I want you to try graphing. After that, what we're going to do is explore a bit on a different website. So yeah, go ahead and take a minute. If you're the type of person who really likes to write down notes, just go ahead and write down what we had come up with there. But otherwise, what we're going to do next is just go ahead and have you get some practice in, and then we will move on to the next section. All right, everybody. So it's time for you to try. You're going to be graphing the equations I'm giving you using slope and intercept. Just remember, it's intercept first, then slope. So go ahead and take a moment to pause the video, and when you are done, you will basically just take a picture of what you've written down or what you've graphed on your computer. You can use a screenshot and just upload it and send it to me. All right, everybody, hopefully you did pause the video to attempt the graphs on your own. If you didn't do that already, please do that. What I'm going to do next is type the equations I came up with into this tool called Desmos, which I want you guys to be able to explore after this activity. And basically what I want you to do is just see if your graphs are correct. Let's check it against that. So the first equation that we came up with was y equals negative 3x plus 2. And your graph should look something like that. Now yours will obviously have arrows on the end. This Desmos thing goes on infinitely because it's a graphing calculator basically. But what you do notice is a couple of things we went over here. We are at 0, 2, that's our intercept, right? So you would have it hit the line at 2, and that would be the first point you would plot. The second thing that you would see is that it has a negative 3 slope. So if I go down 3, 1, 2, and then 3, I'm at negative 1 right there, and then I always have to go right 1, which would be right here. This point right here, if I were to highlight on that, it would go at, whoa, right there. I can't do it perfectly. Man, this thing is precise. But basically, you would see that you would hit the point 1, negative 1. So, and you would just connect the dots from there. That would be your first equation. So it should look like that. It should be a line going up to the left like this, 0, 2, and at 1, negative 1. Awesome. Now, our next one that we had was 2x minus 4. That would look like this. You would first plot the point 0, 4, or negative 4, excuse me, 0, negative 4 right there. And then you would go up 2 and right 1. So to go up 2 from negative 4 would get you up to negative 2. And then you go right 1, and it's right there. You would have put a dot right there, and then you connect them, and you would make this same line right there. So that would be the second one you come up with. Let's look at the third one. 1/3 x minus 5. That did not type in correctly. 1/3 x minus 5. Here we go. So 1/3 x minus 5, we would have the y-intercept at 0, negative 5 right there. And then the slope of 1/3 would basically just go up 1 to 4 and then right 3 right there. So you would put your second point at 3, negative 4. So that would be your your third line, excuse me. You just connect them there. And your last one would be negative 3 over 4x plus 3. So we have the plus 3, 0, 3 right here. Then we would go down 3 to go to 0, and then right 4, which would be at 4, 0. So you should plot the point 4, 0 and 0, 3. And you connect the dots to the line. Now, you might have noticed in all these graphs that there was a second point already put in by Desmos, but each time it was on this x-axis line right here. Now, this particular graphing calculator just is plotting the intercept, so it's going to be the y and the x-intercept. X-intercept is something you actually have to solve algebraically for. We'd have to do the equation, we'd have to solve the equation basically. So I'm not really teaching you that part of it right now. We may go over that later when we're talking about solving equations, if we wanted to find intercepts to solve an equation. But for the time being, you don't really need that to graph this. So not every point that's coming up on Desmos here is necessarily the point you'd want to find. It's basically, I would just go down 3, right 4, and it coincidentally added up to that. But if I go back 1 to this 1/3 x minus 5, you'll notice that this one's actually off the graph of what I'm showing here. The other point would come up around, let's say like 12 or something. But we would start here, same point you always want to start with, but then you would just need to go up 1 and right 3, and you'd find your second point right there. So that's what your graphs should look like. What I want you to do now as an activity is just have some fun playing around with these different equations and whatnot. Now, what you're going to do is go to desmos.com. So I'll spell it right here, and this thing will let me do it. Desmos.com. That's an online graphing calculator. If you search that in Google, it'll say online graphing calculator. You just go ahead and click that guy. What I want you to do next is start with the y equals, input any slope that you want. Just start messing around with it. And then put x, and then plus or minus, and then your b. So I want you to insert slope, and I want you to insert y-intercept. And you can mess with what's positive and what's negative. And what I need you to do is go ahead and take a picture of, let's say, 5 different equations that you came up with using Desmos. And you just got to show me the graph. And what I want you to do is write down the, well, actually, you don't really need to write down the y-intercept. Never mind. I just want you to show me the equations. I want you to see that you're exploring with this and that you're starting to understand what y-intercept is and how both that and slope would affect graph. So again, take a moment here, do 5 equations, take pictures. I want you to explore with the x and the b inputs and all that. So yeah, just go ahead and take a moment, pause the video, explore Desmos, and then we will do the last thing that'll wrap up this lesson. Hey everybody, welcome back here. So basically what I want to show you next is the idea of graphing systems of solutions. So what I'm going to do here, I've been playing around with the features just to see how well it works here. I'm going to show you how to do it. So I can just type in part 1 for Desmos here what the first equation I want is. I then click right here in this empty space where the 2 is, and I just go ahead and type in an equation. Let's say that was it. And to find a solution for a system of equations, now a system of equations is when you have more than one equation that will have the same solution. So we're basically trying to find values for x and y that will work for both equations so that they equal out. And it's kind of like solving a puzzle, if you will. So when I look at this, I can use graphs to solve the system rather than algebra and calculation. There's a lot of different ways we can approach this. When I plug both of these equations in, this place right here where they meet, 2.7 and 4.1, is the solution to this system. So that means if I were to plug 2.7 in for x, so 2.7 here for x, and then 4.1 in for both y's, they would come out as equal. This, 3 times 2.7 minus 4 is 4.1. And negative 1/3 times 2.7 plus 5 is 4.1. So that's how they would end up being equal, and that's what it means to have a solution for a system of equations. So this is pretty cool. Now I did mess around with this a bit off camera just to kind of see how the functions would work. If you were to try and plug in like a third or a fourth equation, you could do that. It doesn't necessarily mean you're going to find a solution for all 3 systems or for all 4 systems or however many you want to show. But you will find overlaps between different sets of solutions, basically. So what I want you guys to do next is just take like 3 problems where you're doing a system. So you can do 2 or more different equations in the form of y equals mx plus b. And what I want you to do is put them onto this Desmos tool, put them into the graph, and then take a picture of it with your phone or like a screenshot on your laptop and just upload that with your work to the Google Classroom. You can even graph it by hand if you're somebody who really likes to write it out by hand, and then you can just take everything as like a picture together as one file with your previous work. So go ahead and take a minute to do that. And when we're done there, we'll do our homework, if you will, our wrap up for the lesson. Alrighty, everybody. We have reached the end of the lesson for today. So basically, what I have here are 10 problems for you to do for credit. So if you complete these problems and upload them to the Google Classroom for me to see, you will be able to get some points. So what you see here are 8 problems that are single equations, so you're just graphing using slope and intercept into systems. What I expect from you is that I would like you to graph these by hand, or you can even use a whiteboard app like I have here. I'm going to include a link to the resources on the Google Classroom. So if you don't have a pen or pencil and some paper, you don't have the resources to participate, you can still use the whiteboard app. What I do not want you to do, though, is to just plug these equations into Desmos and have it graph it for you. Now, if you do get stuck on 9 and 10, I don't mind if you give it your best shot, you graph them, and you're not really sure where they cross, like they're in between lines. If you want to use it to check the precise numbers that are behind it, like you would in a graphing calculator, I'm okay with you doing that for 9 and 10. But what I do not want you to do, again, is use it to actually fill out the graph for you. I want you to be able to graph these lines on your own. So just as a summary here, you take the intercept first, that's that last number, right, along with the sign, positive or negative, and you go up or down on the y-line and plot it on the y-line. Then you apply the slope. If it's a whole number, you're going to go up or down, depending on the sign, that whole number, and then write 1. If it's a fraction, you're going to go up or down, depending on the sign, the top number, and you will always go right the bottom number times. Then you just connect them into a line, and you've got yourself a graphed line. Now, if you want to find the system of equations, the solution for those, you're basically just going to see where the two lines that you graph touch each other. So that is basically it for today's lesson. You've got these 10 problems right here. I'm going to, again, take a shot of these and upload them once more just so you know what you should be doing. And if you have any questions, you can talk to me during my office hours. I'm going to be posting them online here. And you can, of course, feel free to send me an email or something, and I'll respond as soon as I can between lessons. But that is what we are doing today. So I hope you guys all get the opportunity to log in and try this out. And if you guys have any questions at all, you just let me know, okay? Good luck to you all. And again, I want this submitted via picture or screenshot. I want you to upload that. So if you've got I'll post like a little short video of how we're going to be submitting work in just a bit. But yeah, what I want you to do is either take a picture or a screenshot using a whiteboard app, something of that nature for you to do your work. Alrighty, you guys, take care.